Okay, so we are going to pick up where we left off. We went through standard 15 last class period, so we're going to start with 16a, which is solving by graphing and substitution. Here, we're set up to do substitution because we have a variable solved for, so we have x all by itself. So I can take whatever x is equal to, in this case, 2y plus 13. Oh, maybe. And I'm going to plug that in for x. So I'm going to replace the x in the other equation. So I have 5, and then where x is 2y plus 13 plus 5y equals 20. Now start by distributing here, so that gives me 10y plus 65 plus 5y equals 20. Combine like terms, and we get 15y plus 65 equals 20. Subtract the 65 from both sides. We get 15y equals negative 45. And we divide both sides by 15 to get y equals negative 3. Okay, so that's the y value, but I still don't know what x is. So once I've found y, I can plug x back into either equation. However, I think the easier equation would be easier since it's already solved for x. So plugging in negative 3 for y, I get negative 6 plus 13, which is 7. So x equals 7. And then my final answer I can write as an ordered pair, 7, negative 3. Remember, x is always written first. All right, and that is substitution. So cut another example. Okay, these are still systems, but these ones are set up for elimination. I know they're set up for elimination because x and y are on the same side of the equation in both equations. So I need to decide what I can multiply by so that when I add these two equations together, something cancels, something becomes 0. So looking at the two, I'd really like to have a positive 7 here. I think that would be the easiest way to go. But to do that, I'm going to have to multiply this whole equation by negative 7. So negative 7 times negative x is 7x. Negative 7 times positive 10y is negative 70y. And negative 7 times negative 10 is positive 70. Okay, now that I've multiplied, I'm ready to add straight down. I get negative 7x plus 7x, which is 0. That's what I wanted to happen. That's what I expected. Here, when I add straight down, I'm going to get negative 63y equals 50. Divide both sides, and I get y equals negative 50 over 63. I'm just going to leave it as a fraction. And we're going to take that fraction and plug it back into one of these equations to find the y value. So plugging into the top equation gives me negative x plus 10 times negative 50 over 63 equals negative 10. So I have negative x minus, that would give me 500 over 63 equals negative 10. I'm going to add this to both sides, or the minus, and you can just put that in your calculator. So you do negative 10 plus 500 over 63, and you get negative x equals negative 130 over 63. Multiplying both sides by negative 1, we get x equals 130 over 63. And then we can write our answer. And we're done. Okay, and then when you get to word problems, it's still the same two things. So we're either doing substitution or elimination. Looking at 17a, it's a coin problem. And this is one of the more tricky coin problems. So if you need to pause as I go along, make sure you do that. It says Ed has 6 more quarters and dimes. Oh, sorry. 6 more quarters and dimes. If his total is $6.05, how many of each coin does he have? Well, I'm going to start with this $6.05 because we have lots of problems like that. That one's usually the easier equation to come up with. So we have quarters and dimes. I know a quarter is 25 cents. Plus I have 10 cents for every dime. And that's going to equal 605. Remember, you can drop the decimal points as long as you do it all the way through. Then Ed has 6 more quarters than dimes. So the number of quarters is equal to the number of dimes, but there's 6 more, so plus 6. All right, this is a system that's set up for substitution because Q is all by itself. I can take all of this and plug it into my other equation for Q. So now I have 25 times where Q is, I'm going to put D plus 6 plus 10D equals 605. Here I'm going to distribute. That gives me 25D plus 150 plus 10D equals 605. We're going to combine like terms, and that'll give me 35D plus 150 equals 605. Subtracting the 150 from each side, I get 35D equals 455. Oh. And if I divide by 35, I get that D equals 13. So I have 13 dimes. And then we knew that we had 6 more quarters. So my number of quarters is 13 plus 6. So I have 19 quarters. There we go. So the first kind of system word problems was a coin problem. So now let's try a rate, time, and distance problem. But we're going to need to make a small change. So looking at 17b, it says 2 stations in St. Joe and St. Louis are 320 miles apart. So I have my 2 stations, and we know this total distance is 320. At noon, a train starts in St. Joseph and travels towards St. Louis at 70 miles per hour. So it leaves here, traveling in this direction. After 2 hours, another train starts. It should be from St. Louis. So it's starting here and going the opposite direction. On the same path between the two at 20 miles per hour. At what time will they meet? So we want to know when they're going to come together. So when their total distance together is going to be 320. So first of all, we need to know that it's rate times time equals distance. And that if we're looking at something like this, where we have a total distance, we have the distance of the first train plus the distance of the second train is going to equal the total. Okay, so you have to decide if you're adding the 2 distances, like this problem here, where we're wanting to see when those 2 distances will add up to 320, or a lot of times we have them going in opposite directions. It could look like this also, and add up to 320. Or is it one where we're going to set them equal, like you went to the grocery store and came home, that distance was the same, so those 2 distances would be equal. Or it could be like you're trying to catch up with somebody. You're trying to reach the same place, then you're going the same distance, then they would be equal. But this one we're going to add because we have a total distance. We want to know when they will have covered the whole span of 320 miles. So we're going to set up our table. Rate times time equals distance. Nope. Okay, we have train 1 and train 2. Train 1's rate was 70, and train 2's was 20. And we know that we don't know, let's see, well, we do know. It says train 1 left 2 hours before the other. So however long this train's been traveling when they meet, the first one's been traveling 2 hours longer. So we write that t plus 2. And we want to know when the total distance is going to be 320. So the distance of this train is its rate times its time. So that's 70 times t plus 2. Plus, the distance of this train is its rate times its time. And we want to know when the two distances together equals 320. Okay. Okay, so distributing here, I'm going to get 70t plus 140 plus 20t equals 320. Then we combine like terms, so we get 90t plus 140 equals 320. Subtract the 140, we'll get 90t equals 180. Divide by 90. And we get t equals 2. So train 2 has been traveling for 2 hours. That's what t is. Train 1 has been traveling 2 hours plus the 2 that it had head start. So it's been traveling for 4 hours. So if it left at noon, it is 4 o'clock when they meet. All right. That's a rate, time, and distance. So now let's look at 17C, which is a population problem. Oh, not quite there. There we go. And I actually think these are some of the easier systems because we've been writing this type of equation all year long. So it says the number of calculators in stock at Central are 240 and increasing by 30 each year. So stopping right there, I have the number of calculators is equal to 240 plus, it's increasing, it's going up, 30, and I know what it says each year, that's where my variable is. That's my rate of change. Okay, then number of calculators at Math Warehouse they're starting out with 10,000 and decreasing 8,500 a year. How long will it take for the two to have the same number of calculators? So we want to know when these are equal. Well, this is just substitution. You have y equals all of this stuff. So, undo. So I can take all of this and put it where y is over here. So now I have 10,000 minus 8,500 x equals 240 plus 30x. Okay, so I'm going to start by adding the 8,500 over. So that gives me 10,000 equals 240 plus 8,530x. Then I'm going to subtract the 240 to the other side, which is going to give me 8,550. Oops, sorry. I have a different number. We're okay. Okay, so subtracting the 240, I'm going to get 9,760 equals 8,000 530x. Okay, and then we're going to divide by the 8,530. And we get x equals about 1.1 years. All right. Now turning your packet to standard 17D. These systems are a little more just a mix of the different kinds you can have that are not necessarily following a specific pattern like the rate, time, and distance or coin problems do. Okay, but sometimes they're much easier to solve. So here we have the distance of two numbers is 102. So my two numbers I don't know, so I'm going to call them x and y. And I know difference means I'm subtracting. So when I subtract x and y, I get 102. Then it says the sum of the same two numbers is 1124. So that means when I add the two numbers, I get 1124. Draw my line. This is set up for substitution, set up for elimination. My x and y are the same side. And the negative 1y and positive 1y is going to cancel out. It's going to give me 0. So I don't even have to multiply to do this one. X plus x gives me 2x. And over here, I'm going to get 1226. Oh, is this a 4? This is a 4. There we go. That makes more sense. Dividing by 2, I'm going to get that x equals 613. Then to find y, I just have to plug it back into either equation. So I have 613 plus y should equal 1124. Subtract the 613 and I get y equals 511. Okay. Now this next one I'm not going to solve for you, but we're going to see at least if we can set it up. So senior class at Park Hill and Blue Springs planned separate trips to New York. The senior class at Park Hill rented and filled one van and 6 buses with 372 students. So I'd set this up, one van worth of kids plus 6 buses equals 372. Then Blue Springs rented and filled 4 vans and 12 buses, totaling 780 students. Okay. So sometimes these are really actually quite easy to write if you just take it one sentence at a time and write one equation at a time. And then just like the one above it, this one's set up for elimination. You just have to decide what you need to multiply this equation by in order to do that. And I'll let you finish that one on your own. Let's look at standard 18. Okay, standard 18 is graphing systems of inequalities. Okay, so if these are equal signs, we look for where the two lines cross, and the point where they cross is our solution. We write that ordered pair and we're done. But when we have these symbols, that's when we have to decide if we're going to have a solid or dotted line, shade up or shade down. So let's write a little note. If it's either one of these, it's a dotted line. If you have the or equal to part, it's a solid line. Then, if it's less than or equal to, you're going to shade down. So that's where the y values are less. If it's greater than or equal to, you're going to shade up. Because y is greater than that, and the y values are higher above. Okay, so let's try this first one. We're going to start at -4 because it's my y-intercept. And I'm going to go up 9 over 1 with my slope. And because there's no line underneath, I want a solid, or not, sorry, I want a dotted line. Oops. Okay, so I'm going to draw a dotted line through those 2 points. And because it is less than, I'm going to shade below. Okay, and then for the next one, I'm going to start at positive 5. I'm going to go up 2 over 1 because my slope is 2. And because there's no line underneath, I know it's a dotted line. Okay, and we have y is greater than this stuff, so we're going to shade above this stuff. Right here where these two overlap, the two shaded regions overlap, that's where your solutions are. All right. Remember to pause as needed. I'm going to move on. Oh, hint for number 3 when you get there. Remember Hoy and Vux. Horizontal lines are y equals just a number, and vertical lines are x equals just a number. Okay, but looking at an exponent problem, let's look at number 1. The first thing I have to take care of is this 3 on the outside, so I'm going to take everything in here to the 3rd power. Well, negative 5 to the 3rd power is negative 5 times negative 5 times negative 5, which is going to give me negative 125. Then this is to the 1st power if there's nothing written. 1 times 3 is 3, so I have x to the 3rd power. 8 times 3 will give me 24, so I have m to the 24th power. And n times, or sorry, not n times 1. 1 times 3 gives me 3, so I have n to the 3rd power. Now, bringing this down, I had 2x to the 3rd, m, n to the negative 2. Okay, so now starting by just multiplying the numbers, 2 times negative 125 is negative 250. Then when we multiply, we add exponents. So x to the 3rd and x to the 3rd is going to be x to the 6th. M to the 1st, because there's nothing written there, and m to the 14th is going to be m to the 15th. And m to the negative 2, sorry, n to the negative 2 plus 3 is just going to give me 1. So actually, it was very lucky there because I didn't have to deal with that negative exponent. Though remember, if you do, you move it over the line to change the sign of the exponent. Okay? All right. Go ahead and let's look at the last page of this review. We got just a couple more problems that I want to do. These ones are really quite easy. It says rewrite the expression in either radical or exponential form. So to take this back to a radical, a root, which looks like this, these problems here, whatever number is on the bottom of this fraction goes on the outside here. So this is the 7th root of whatever's in parentheses, so AB. Okay. So once again, whatever's on the bottom of your fraction goes on the outside. Then we can go backward. Whatever's on the outside goes on the bottom of the fraction. So this is 2x to the 1/4 power. I'll let you finish the next two on your own. Then we get down here and we're adding and subtracting polynomials. So I will do one of each with you, starting with adding. I'm going to rewrite this so I have a little bit of room. I have 3x to the 3rd minus 5x squared. I'm going to leave a little bit of space and put plus 10x, or sorry, plus 10. in case I have just an x to the first power that I need to line up. Then looking at the second, I'm going to line these up so that the powers make sense. You have to line up the third power with third power, second power with second power. You cannot add things together if they do not have the same exponent. So here, I don't have anything to the fourth power here. I don't have any exponent of 4 here. So I'm going to write that out in front. Okay, and then I look for third. Well, I don't have anything for the third power here. Second, I have 7x squared. First, I have 8x. And then I have minus 4. And I'm ready to add straight down. That's going to give me 11x to the fourth. Plus, this doesn't have anything to combine with, so 3x to the third. Negative 5x squared plus 7x is going to be x squared. Can add these two together because they have the same exponent. So that is 2x squared plus 8x because that has nothing to combine with. And then 10 plus negative 4 is 6. So there is my final answer. Okay, looking at subtraction, it's the same idea, except we're going to distribute this negative sign first. So that's negative 6m to the fifth minus 3m plus 11. So here I'm going to write these from the biggest exponent to the smallest. So that gives me 4m to the seventh plus, the next one would be m to the fifth minus 4m minus 9. And I kind of give myself some room in case I have something to the sixth power or the fourth or third to combine with this. Now going through here, I have negative 6m to the fifth. Well, I had a fifth power, so I'm going to line that up right there. Minus 3m and plus 11. And I'm ready to add straight down. So that gives me 4m to the seventh minus 5m to the fifth. 1 plus negative 6 gives me negative 5. Negative 4 plus negative 3 gives me negative 7m. And negative 9 plus 11 gives me positive 2. And that's it. All right, complete the rest of these for practice and make sure you spend some time studying this weekend and get ready for your test next week. Remember, you have to show me that you know at least 60% of all the math standards, which you can all do. Okay? So work hard and I'll see you next week.